In this problem, we're told that electrons are emitted from a surface when a wavelength of 612 nanometers is shown on the surface. So with that wavelength, we are observing the photoelectric effect. But anything longer than this, any greater wavelength, there's no photoelectric effect observed. So what is the work function for this material? So when you're having to do with the photoelectric effect, those electrons that are being released, they have kinetic energy that's equivalent to the energy of the photon, Planck's constant times the speed of light divided by the wavelength, minus the work function. So the photon has some energy. It requires energy to remove that photon. What's left over is the kinetic energy of the photon. And we're kind of looking for the starting point here to say, okay, if our wavelength is anything more than this, we don't have any kinetic energy going on. So this kinetic energy is going to be equivalent to 0. I'm going to move the work function to the other side and say, when we're doing the very beginning point, the work function equals the energy of the photon. So Planck's constant times the speed of light is 1.24 10 to the third electron volts times nanometers. But divide that by the 612 nanometers we're given. And so we get a work function here of 2.03 electron volts.